Hi everyone, in this video, I'm going to go over electrochemical sales lab that we will do this week. Okay, so these are the topics that we'll cover in this pre-lab video. So the goal for this lab R1 is to observe spontaneous redox reaction and relate that to the change in gift-free energy. The second one is for you to learn how to construct electrochemical cell, which is a galvanic cell, okay, so that rely on the spontaneous process, okay. And then you are going to also measure the voltage or the chemical potential that come from that reaction as well. Next, I'm going to go over the procedural overview. Okay, so part A, what you are going to do is you are going to make observation of the two reaction of the redox reaction. Okay, so based on your observation, then you will need to determine whether one is spontaneous or not, right? And then relate that to the change of gift-free energy. The first reaction is going to be the magnesium metal in copper sulfate solution. Okay, so the second one is going to be the copper metal in magnesium sulfate solution. You are going to observe which one is going to undergo chemical reaction. And that observation can be written here. Okay, so if there's nothing happen, you still need to jot that down, right? So that was still going to be your observation. Okay, so whatever that is undergo changes, so that changes is going to indicate that that reaction is happened spontaneously, right? So that delta G would be negative. If nothing happened, then that reaction would be non-spontaneous in the forward direction. So that means the delta G would be positive. In terms of the chemical reaction, what you are going to do is you are going to use the replacement reaction to write out this. For example, this X is going to represent the metal that you use. For example, it can be either magnesium or copper, right, for this one. And then YZ, this is going to represent the solution that you use. So for example, it can either be magnesium sulfate or copper sulfate. Therefore, your final product here would be the result of the exchange of these two. For part B, you are going to construct the electrochemical cells and then measure the cell potential. Okay, so for each of these pair. Okay, so the electrochemical cell composed of metal ion solution. Okay, so electrode, right? So contain two electrode and also salt bridge as well to complete the circuits. And you're going to connect this to electrode with the voltmeter to determine the voltage or the cell potential for the reaction. So this is what you are going to construct in the lab. Okay, so for example, if you have copper and tin, right? So the pair of these two is going to be one, you're going to use the tin metal as the electrode. And then this is going to be soaked in the tin solution, tin ion solution. And for the copper electrode, you are going to use the copper wire. And then you are going to use the copper sulfate as the solution. Okay, so these two solutions are going to be connected by this salt bridge, which is the saturated potassium chloride. Okay, so, and these two electrodes are going to be connected through this voltmeter to read the cell potential. Okay, so note that you are going to only record the positive E cell. If you construct this and it's giving you a negative value, all you need to do is swap this alligator clip. Okay, so that way you can swap the electrode and you are going to only record the positive value, okay, which is indicated that it's going to be spontaneous redox reaction. Okay, so after you're done, again, you are going to put those pair into this table right here and again, only record the positive value. Okay, so, and then you will need to determine the number of mole electron transfer between those two metals. For calculation, part B, so what you're going to do is that you are going to use the experimental value of the E cell that you receive, right, from your experiment in part B and plug into this delta G equation. Okay, so plug in the constant, and then from number of mole of electron, you're going to get the delta G. So after you get the delta G in joule, then you need to convert that into kilojoule. For the result in part B, again, you are going to record only the positive cell potential. Okay, so you're going to determine the anode and cathode accordingly, and you're going to calculate for the delta G accordingly as well. Okay, so next I'm going to talk about how to write out the oxidation half reaction and also reduction half reaction as well. Let's take a look at an example of the result from part B. Okay, so let's say that the metal that I have would be Y and X. Okay, so let's say that the metal ion that associated with X would be X plus, and the metal ion that associated with Y would be Y3 plus. Okay, so again, in order to write this out, you need to determine the correct anode and cathode. So that means your E cell have to be positive, right? So whatever that gives you positive, you are going to record that accordingly. And the reason why I use Y as anode and X as cathode, because it gives me the positive cell. Okay, so according to your cell potential value, you should also get a negative value for the delta G as well, because this is spontaneous redox reaction. Next, I'm going to talk about the half reaction. Okay, so note that the oxidation will occur in the anode side. So therefore, in this case, the oxidation half reaction will include Y. Okay, so I'm going to, because it's oxidation, right? So that means Y need to lose electron. Okay, so it's going to go from Y to Y3 plus. Okay, so how many electron in this case? Then, well, this is 3 plus, so therefore it's indicated this Y losing 3 electron. Okay, so for X is part of the cathode. Okay, so reduction happened at cathode. So therefore, in this case, X would be the one that is undergo receiving electron. So remember, we have X plus. So therefore, in this case, it's going to be X plus receiving an electron become X. Okay, so note that the number of electrons would need to transfer equally for both oxidation and reduction, right? So therefore, in this case, you will need to multiply everything for the reduction half reaction by 3 in order to make the number of electron transfer to be equal. So that means for this electrochemical cell, the number of electron transfer total would be 3. For the post-lab question, I would like to highlight number 5. Okay, so number 5 asks you about what happened if you remove the salt bridge. So that means during the experiment, after you already obtain the value of the cell potential, you might want to remove the salt bridge in order to observe what happened. Okay, so that way you can see how it affects the reading on the voltmeter. And note that for number 7, the electrochemical cell that you need to construct here have to be the galvanic cell, which means it have to be spontaneous redox reaction.